Hello, everybody. Hello. Thank you for the invitation to this workshop. I'm going to speak about the deep learning and weed detection and integrated with management content, which is the um, framework that we use for controlling weeds in general, and in particular how the deep learning is improving radically the way as we do several stages under this scheme. Okay, I belong to the Instituto of Investigaciones Agropecuarias in INEAS. Is more or less a similar institution like ARS in US. Is a public institution dedicated to agricultural research in general, many topics. Chile is a very long country situated in South America. Is have a lot of different climates, very dry climates in the north, a transition zone in the middle, and a very cold climates in the south. So we're going through many kind of climates and soil conditions. There is a lot of variability in this sense, except I will say that we don't have tropical crops in Chile. We have all the other crops like cereal crops or fruticulture, viticulture, etc. And we are, as institute, we are located in all the places on Chile. So for doing all this research concerning which are the higher or most important challenge in our agriculture, like today the climate change that is affecting us, particularly in Chile with the dry seasons last years. Well, under this problematic in general in agriculture, I could say that the approach to deal with the weeds is an integrated weed management, or IWM, which is no other thing that selecting some tools, several tools, like a cultural approach, like mechanical approach, biological approach, and of course the chemical one, in order to apply the most broader range of techniques that we have availability today to combat the weeds. In the cultural approach, for instance, we are doing the best with the crop in order to cultivate well the plants, that they are, simply speaking, we are trying to do the best with the crop in order that this is growing up very vigorously, very robust, a good rate, in order to cover the soil before the weeds are covering the soil. In the mechanical approach, we are doing several works with mechanical things, like are going and taking out the weeds from the soil directly with the help, many times with the help of machinery. And the biological approach is we are using some tools like microorganism or major organisms, in order to feed in particular stage of the season, but this in particular is very successful in different aspects of vegetal sanity, or in agronomy is very used. but in particular in wheat it is not very used because it's quite limited. And the mechanical one is limited because have some constraints, like generate some process of erosion in soils. For instance, you are taking out many seeds from the soils, and you are many times regenerating new infestation in the season, etc., etc. So, but are very valuable tools that we have to consider in a integrated scheme. And finally, we have the chemical one. The chemical one, by far, is the most used today in the agricultural sector worldwide. This is responsible of the more than 90% of the control in vast areas of cultivation worldwide. So this particular tool, the chemical one, is very important, but have some constraints, some problem related specifically with this zone, that is the application in a broad scale in the soil. So you have to apply over the crop. Those are selective herbicides. You apply over the soil, and in the soil logically are the weeds, but these have some contamination, have a certain side effects. So the people is concerned, and as a result, we need to rationalize these tools, especially the chemical one. So the key aspect that we as a group and we as specialists, both internationally, the agreement in the Wheat Science Society is that we need to see very well the targets. Okay, we need to see the target in order to apply the herbicide in this case, or even the mechanical tool where the weeds are. I don't want to disturb the soil at the side of the weeds. I don't want this side effect to disturb as less possible, only in the weed. This is the key aspect in order to rationalize, to reduce the amount of chemical active ingredient per hectare or per acre. Because according to many studies, no less than 50% or until 95% of the application could be reduced, especially the chemical one. And this will have potentially big impact in the agricultural sector. Okay, so seeing that weeds for doing this integrated weed management is a different levels, not only at the level of the plant, the little plant in the soil, like I show you, but you have to do this observation through the season, from the early crop to the harvest, okay, in one particular season. So you have to take these developmental stages and starting to scouting the crop, and you have the opportunity to observe and map these weeds from the very early stages through the middle stages to later stages until before the harvest, because you in all the stages you will have problems with different emergencies of weeds. At the first stages here, you have to control in order to reduce the impact on the yield of the crop here. Afterwards, you will have some problem that when you don't succeed in this part, you will have to evaluate here. Okay, you will see, oh, why I have those weeds in the soil on this part. Okay, you have to take into account. I'm making an scouting here for improve the situation in the next seasons. Obviously, in the harvest season, you have to take notes and map, obviously, these situations, and this multiply by several seasons. You in this same soil, you will have another crop, and you will have perhaps another situation, and you will need to take notes of this particularity during several seasons. So, and also in the spatial domain, in one single paddock, you have different seedlings growing, but when you take out zoom out the situation, you will have different scales of the problem. You will have these clusters of weeds that you can observe. For instance, in altitude, you will have these communities of plants, not only one or two species, but are multiple species that are infesting different parts of the paddocks. And finally, you will have a complete community in several fields that you have to take into account in order to make a better solution for a grower which have several paddocks. Okay, and this is one of the lead of the site-specific weed management, which is a concept that born in the 1990s, and really today is a very hot topic in the community of weed science, because this capacity of mapping through the new technologies of observation of the plants really is possible with this. And as I told you, in the 1990s or the 2000, we had some dreams about. We have some observation, some prototypes with the data controller processors, and after with the spray of the weeds. Afterwards, all this cycle through a machine. The researchers were started to dream with some integrated system like this. Okay, but this was not possible because of the observation. This part was the bottleneck. This part in the computer power was a constraint, but not so much. And finally, in the spraying systems are ready to go nowadays. But the other part was not very well assumed. Afterwards, there were a lot of works on this sense. In 2009, for instance, these works on University of Bonn in Germany. Those guys did a lot of maps of application with tractors, with a lot of technologies, but was not successful because the technologies for observation were very, very local. And really, these were very good approaches. Even today are very, very good, but were not successful in the broad sense. But after the AlexNet and after some first works in weed technology area, there was a plethora of works of people running on the deep learning modeling in order to do some observation on weeds. And obviously there were some pioneers in the industrial area, like Blue River Technologies here in US, where they applied this they lemma were see and spray, which was the same one that we had there in 2000. But they took a reality point after the deep learning technology arrived to this specific topic for them in very broad scale of soybean production with some limited amount of weeds that they are like amaranthus, etc. Nowadays, there is a plethora of this. This is a big trend in control. The same scheme of the Blue River technology is being replied by many companies around the world, especially in Europe, for this intelligent bar, for instance, Eco Robotics, some Carbon B in Germany, in France, etc., etc., and also the robots. The robots are very important on this scheme and are taking part of this revolution. And we are here in Chile, where we are expecting for these revolutions. So, but we have two ways to incorporate this. We need to do our own models in order to apply this technology well. And the other is that for the integrated weed management, we need to make a good scouting, proper scouting, in order to know which is the distribution of the weeds. So, which is the work that we started with is the evaluation of weed detection techniques by using deep learning models, using several scenarios, which means several scenarios. For in Chile, we have a lot of soils that are alluvial soil, volcanic soils, soils that are constructed in the same site, are not alluvial, many crops and many weeds. We have at least 50 several weeds that we have of importance. So the consideration are many, and we started to tag these weeds on some platform for tagging, for labeling. This is the supervisory labeling tool that we started to make a lot of combinations in order to evaluate in our environment. Okay, and we were doing this in the last 2 years in canola, in wheat, in lentils, chicory, in bare soils, and sugar beets, in captures in different times during the season for several weeds, at least 9 weeds. Distance 1 meter, 50 centimeters, 20 meter in aerial with drones, and in different stages. So we were evaluating these techniques in order to evaluate their robustness, evaluate their accuracy and F1 indexes, and also the capacity to recognize weeds in real time. Okay, we need to say that the weeds that we are talking about here in the last slide, that are weeds that are present here in US. These are almost exactly the same weeds because they are worldwide present. Okay, in all the sites, all the sites have the distribution of those weeds here in US, and you have patches of all those weeds, very concerning infestation. For instance, Ambrosia artemisifolia, etc., but are almost the same weeds. The ecotypes naturally are different, are certain differences, and especially to the resistance or to herbicide that we have in every country. In the modeling side, we were working especially using the YOLO family, the you only look once family of models for the object detection of the deep learning. We were basis starting for YOLO before, and before there was the YOLOs of V2, V3, etc. And there is a lot of YOLOs nowadays in the literature and applied. You have repos for all this, obviously. And we have doing things with YOLO before and YOLO R. YOLO R is you only need only one representation. This is another scheme. In general, the YOLOs are taking one input images, one input, and through the backbone of the model that is generally in YOLO before is the so-called the darknet 53 backbone, is taking out some features in different part of this backbone feature, from large object detection, medium scale detection, and finally a small detection. And in some part in the algorithm is the output is integrating all these different detections. Okay. Also, we have apart from logically, apart from doing the labeling, we export this to other tools in the internet, like this raw flow tool, that for us that we are agronomists. We are not computer scientists, so we need some tool like this in order to facilitate the work and the evaluation and compare with the things in the field. So we are learning a lot with these tools like raw flow, because those guys are discussing in their blogs, etc. It's a very rich environment to advance and to discuss. Okay. And we submitted this data to different transformation, like some very important to us is the saturation of brightness, that is very typical to change in the field. The blur also, because some images and some frames in the videos are blurry, and obviously the noise. This is always we are taking into account those transformations. But perhaps in some works we also use the exposure and the shear transformation. Okay, and the other thing that is very necessary to take into account that is we are doing with these tools. For instance, you have the possibility to export to many formats. The same labeling is very good to have the possibility to export to different formats in order to evaluate different kind of models. Because of this, we were taking these models in other frameworks and were not so successful like in the YOLO ones. Okay, so we form a very interesting data set with different levels of illumination, with different exposure, more or less the same thing that we see in the field. You can see here you have una lentils crop. These are the lentils, and these very little are the weeds, and you notice that weeds are reddish. This is a very special but common weed that is a Polygonum aviculare, that is in the first stages is red. Also, afterwards it's turning to green, but in the first stage, when you have to take decisions, are red. So this was very hard to detect before the arrival of the deep learning models. So with this we did some modeling. The modeling we regularly we are using the public repos that are published in GitHub. Some of the tools we regularly are doing our modeling in Google Colab, for instance, and we are doing the metrics in order to compare the different models. And this is a comparison of some of the models that we have in wheat, in raps, in maize, in chicory, for instance, and the precision, the recall F1 and interception over union indexes are okay for now. Are okay. They are over 80%, ranging towards the 98% in some cases, and the F1 is quite okay, from 80 to 92%. These are not the definitive metrics that we are going to do. There are other metrics that some colleagues are incorporating in order to serve better to the application with the chemical, with the spot chemical application. The F1 is not the better, but intersection over union is also useful, and we need to manage better some of this index in particular. We need to work more on this. Perhaps this is the lower index that we have so far. Okay, and all these models were developed in different conditions, as I told you, and ranging in all the season. This means from the plant from 1 leaf, 2 to 4 leaves, 2 to 4 leaves, 8 leaves, and flowering stage on different platforms, from a camera in hand to a drone at 7 meters high. Yeah? And we obtained it. Those are some outputs of the test set of the different models. We had different models for each condition, 1, 2, 3, 4, 5, 7, or 20 models that we have so far, and in different conditions for this Raphanus versus Lolium multiflorum here, Viola arvensis, very tiny weeds in 1 square meter. This is 1 square meters. Okay, this complete was you have to manage this scale, and this is one of the beautiful, according to us, outputs of these lentils that I showed you before. These lentils that you have here, and in here you have a plethora of weeds of Polygonum persicaria. You can see here these reddish weeds that are being detected. As it's very nice, because this, according to us, surpasses many times the ability of the human eye to take notes in the field with this kind of weeds. You can see this. It's very confounding with the color of the soil. And in the umbel, that is Ambrosia artemisifolia, you can see also very well, because it's similar but it's green. Okay, and you see some counting of the crop from aerial basis, some plants of CMIs with some Raphanus here, okay, and some other crops with aerial imaginary. So this is a particular topic very important to us, that is the detection of weeds on rice that are grasses, that are the rice is a grass, okay, and this particular weed, is another grass. This is a Echinoclea crucigali that is very well known here in US as well. Okay, so you have all these tools in order to being applied. This is a YOLO R algorithm. The others were YOLO before. This is YOLO R. YOLO R is very well capable to distinguish very tiny little widths in the images. I am speaking about a few millimeters before are 5 to 1 centimeter of width, and many times you have to recognize a lot of this in 1 square meter, like here. Okay, in 1 square meter you have so many, like 2,000 of these little weeds. So you have to take the advantage of this in order to make a proper scouting work. This is a sum of the situation. And also in the special, this is in the spatial frame, in the spatial domain, but in the time domain, we were proving these models also. These are the same lentils. Is another model, obviously, because it's different. The environment. This is very quickly. These are many weights and are taken in a very good rate, and in that way we have these several models evaluating in different approaches, in different environments and platform. The first and the last were some in drones, okay, and are capable to make a very good scouting capability. This starting point is very good to us, because and that way we are able to evaluate a lot of crops in one single morning. Okay, but our concern is that still we have many crops ahead. In our zone, in my region, that is in the center of Chile, we have more than 10 crops, obviously, more than 20 or 50 weeds. The distance that you can be of interest are at 50 centimeters, 1 meter or 10 meters, and the growing stages of interest at more than 5. So you have 3,000 combination to do. The question is, you are going to do 3,000 models? No. But you have still is concerning, because you have more soil conditions, you have more humidity, etc., 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 etc. So you have many more combinations. So one of our concerns today is, how do we, and you also, I know that, how do we take more or generate more models and have enough data? That's the keystone, or the key story of this moment. Okay, and for the moment we are doing some step that is like a trick, and this is generate some. We are starting with this working and taking cuts from the images. Because are 2D, especially in the first steps, images, and taking a lot of photographs of backgrounds of different soil, different infestation, and the situation of soils, and combining them in order to generate synthetic images. Okay, synthetic images that are going to be modeled afterwards. In order with this, we are generating a lot of more scenario, and we are evaluating it. This is in in progress right now. Okay, has been used recently with other groups, and were successful in their conditions. So we are advancing on this space also. Well, the integrated with management have several groups of action. It's more complex than the one that I presented already before. Have many aspects to be evaluated in the diverse cropping system, in the direct control, in the assessment of cultivar, and of course in the field management. Okay, but the central point, according to some colleagues, especially in Europe, is that the monitoring of an evaluation is central, is key on this scheme integrated, because is the more information that you will have detailed in the field through the years, and you will have a systematization of this information, and you can take proper solutions, and for each field you will have a suitable plan to do in the next seasons. So as overview and remarks, I can tell that artificial intelligence and deep learning will be embedded in the whole integrated with management program. Will be an integral part. So because of this, we are working on that, and we will following working on that. Okay, working in this scheme implies that we have to assume that we have a huge variation on scenario and distribution. The out of distribution, the OOD problem is central to us. Also, I didn't mention this, but this is the reality, that we have a lot of distribution, and we need to put special attention on the advances on solving this problem in particular, how we make a model, and how this model can be generalized to new scenarios. We need to deal with formula and formulate efficient way to train robust model and generalized model in definitive. The other thing that I didn't mention is the machines that we were showing in this presentation are going to work only if integrated with management is active. They will work only if you have a decent amount of weeds present in the field. If you have 2,000 per square meter, those machines will be not be an advantage. Only if you manage and count a population of weeds that are numbers like 3 or 4 by square meter, no more than 10, this could be managed in a better way, and use less herbicide in a proper way. Okay. Also remember that those same images will have several uses, and for this we have integrated framework with other specialists in my institute and in other parts in the world, in order to make uses for entomology, for fertilization, for water use, etc. So in case of any question, don't hesitate to contact me to email or etc. And this is my team in the Web Science Laboratory in the south of Chile, and my collaborators in India. Thank you to all of them, and thanks a lot for your attention.